Let us start the theorem 6.1. The most important theorem for exam point of view. See, if a line is drawn, try to understand and please be alert. If a line is drawn parallel to one side of a triangle, any one side. So here I take a triangle. Let the triangle is ABC. A line is drawn parallel to one side of a triangle. One side I select BC. A line is drawn parallel. Suppose line L is drawn parallel to BC. To intersect the other two sides. This line intersect other two sides. Suppose it intersect AB at point D and AC at point E. In distinct point, different point. The other two sides are divided. Means AB is divided into AD and BD. AC is divided into AE and EC. Prove that these other two sides which are divided, they are divided in the same ratio. They are divided in the equal ratio. Prove that. So what is the data? And data means what is given. In triangle ABC, line L parallel to BC. Line L intersect AB and AC in two distinct points D and E respectively. Okay, to prove what? The sides AD and DB are in same ratio, means AD upon DB, that is equals to AE upon EC. Now proof. See, you have to write the theorem in this manner. Okay, remember that this theorem is also called Thales theorem, or it is also known as basic proportionality theorem. This theorem is also known as Thales theorem because it is derived by mathematician Thales. Thales is the guru of Pythagoras. It is also known as basic proportionality theorem, called BPT theorem, basic proportionality theorem. Is it okay? Now see, again I repeat the concept. Triangle ABC is given, line L is given in the plane of triangle ABC. Line L is parallel to one side of the triangle. We select BC, means L is parallel to BC. If L parallel to BC, then line L intersect AB and AC in two distinct points D and E. Because of this line L, this AB is divided into two parts. Remember, two parts. It doesn't mean that two equal parts. AD and BD are two parts. Here AC is divided into two parts, AE and EC. We want to prove that they are in same ratio, means their parts which are divided are in same ratio. Is it okay? Thales proved this theorem with the help of area. So here also we are going to prove the same theorem with area. Okay? So first step is what? Join BE. You will get triangle BDE, a new triangle. Join CD. You will get triangle CED. So here I write join BE and CD. Is it okay? Now you know that if you want to prove about area, then area of triangle is half base into height. So here bases are there. Let me take BC is the base, EC is the base, AC is the base, AE is the base, and same way different sides. But altitude means the line segment at 90 degree is not given. So here we suppose let DM doesn't mean direct message, DM perpendicular to AC. Let DM perpendicular to AC and EN perpendicular to AB. Is it okay? DM perpendicular to AC, EN perpendicular to AB, we suppose. Now see, what is the area of triangle ADE? Think and concentrate. This triangle ADE, area of triangle ADE equal to half base into height, half base we select AD, so its height is EN. This is what area of ADE. Call it result number 1. Now compare this ratio, area of triangle ADE with triangle BDE, this one. So take also area of triangle BDE equal to again half base into height, BDE. Here we take base is BD. So what is the height of triangle BDE? See, I draw this triangle here. This is BDE. Okay. Now, if you select BD is the base, then you can take EN is its height. Extend it. This is obtuse angle triangle. See, friends, this angle is obtuse angle, right? So if you see this triangle in this manner, this is the board, so I cannot rotate it, but you can rotate your notebook also. So take this triangle like this, means move this triangle in this manner. So BD will be base, D, B, and E. I take EN perpendicular to BD. You have learned that if this angle is obtuse angle, then altitude is outside the angle. Right? You have learned it in previous standard. So here we use that area of triangle BDE equal to what? If you select BD is the base, then EN is its altitude. So BD into EN, half base into height. Result number 2. Now take ratio of number 1 and number 2. From 1 and 2. Area of ADE upon area of BDE, that is equals to half into AD into EN upon half into BD into EN. Half cancel, EN cancel, that is equals to AD upon BD. Result number 3. Is it okay? Same manner. Now once again I repeat area of triangle ADE and then I compare with triangle CED. Here while finding the area of triangle ADE, I change the base and altitude. See again. Also area of triangle ADE equals to half base into height. Here base is AE and see the diagram, height is DM. DM is its height. Result number 4. And area of triangle CED equal to what? Half CED, this triangle. Here we take base is CE and its altitude is outside because this is obtuse angle triangle. So half CE into DM, number 5. Now from 4 and 5 take the ratio. Area of ADE upon area of CED, that is equals to half AE into DM upon half CE into DM. DM cancel, half cancel, that is equals to what? AE upon CE. Result number 6. So now compare the result number 3 and result number 6. We want to prove what? See, AD upon DB. Here we have AD upon DB. DB and BD both are equal. That you can understand. AE upon EC. Here AE upon CE and EC are same. So we want to prove that result number 3 and result number 6 are equal. To prove this, result number 3 and result number 6, we want to prove what? The left sides should be same. See the left side. Area of ADE. Here area of ADE. But now in the denominator, area of BDE and here area of CED. See, BDE and CED. Triangle BDE and triangle CED. Recall your 9th standard. Okay? Triangle BDE and triangle CED, they are on same base DE and they lie in between line L and BC, where L parallel to BC, means I can say that they lie between pair of parallel lines. That means two triangles which are on same base and lying between pair of parallel lines, then their areas are equal, that you have learnt in 9th standard. So here write this line, that triangle BDE and triangle CED are on same base DE and lie between L parallel to BC. Therefore, area of BDE equals to area of CED. Their areas are equal. Call it result number 7. So now you can derive from 3, 6 and 7. You can write that if BDE and CED are equal, their areas are equal, then you can say that AD upon BD, that is equals to AE upon CE, hence proved. Okay? From this also you can derive another result also. Here we prove what? AD upon BD equal to AE upon EC. Now you can say AD upon total AD, that is also equal to AE upon total AC. Means if you select here AD, you must have to select its corresponding side AE here. If you take AB here, you have to take AC here. So I can write from this, not in your textbook but in your course is there, AD upon AB equals to AE upon AC, that I can write. Moreover, you can write also, if you select BD first, BD upon total AD, I can write here CE upon total AC. So BD upon AB, that is equals to CE upon AC. Okay. And moreover, one more thing also, if you take that triangle ADE and take another triangle big one ABC, try to find out the correspondence between these two triangles. Which two? ADE and ABC. Here we take AD, then for ABC it is called AB. If you take AE, then for ABC it is called AC. But if you take DE side, then its corresponding side is BC. Okay, so I can write AD upon AB equal to AE upon AC, that is equal to what? DE upon BC. AD upon AB, that is equals to AE upon AC, that is equals to DE upon BC. Remember this results also, which will be helpful in your board exam. So theorem number 6.1, write it 5 times. Remember, write it 5 times, this theorem. And you have to write this theorem by changing the names. Don't copy this. Copy it only for one time. Means your first time is of ABC. Second time you have to change the name of the triangle, whatever you like, DEF or PQR or XYZ or LMN or whatever you like. Okay? BOY boy or whatever, what you CAT cat or DOG dog. Change this name and write another 4 times. Means one time copy this, 4 times changing by changing the name. Then and then you can learn this theorem. That's it for this theorem.